lecture, I have three basic objectives. The first one is to just define some key terms in logic that you might come across outside of this class. The next objective is to explain the components of a well-formed formula. So a well-formed formula is going to be the way in which we symbolize our logic. So it's important that you understand the basic rules behind a well-formed formula. And then from there, we're going to demonstrate how to translate a statement or a sentence into a well-formed formula. There are a few key terms I would just like for everybody to be familiar with. These are basic terms that are in logic that are just good to know. We'll have some other terms that I'll use throughout the semester, but I'll define them as we go. These, again, are just sort of the most basic ones that you'll come across in logic, and they all are in pairs here, so I just want to go over two of them at a time. The first two are premise and conclusion. So all arguments, which is what we're dealing with here in logic, we're dealing with logical arguments, we're diagnosing arguments, and we're deconstructing them, and we're trying to see whether or not certain arguments follow from other arguments, and whether or not we can say that some things are true or false. That's also something that's important in logic. But the first basic part is to diagnose what an argument looks like, and an argument is composed of both premises and conclusions. A premise is just a statement offered in support of a conclusion, and conclusion is what an argument is sort of aiming to show. So a real basic argument we could give is that, if it rains, I'll take my umbrella. Just gotta shorten umbrella with a U. Second, we could say, well, it is raining. And third, we could say, so I'm going to take my umbrella. So we have three different sentences here. We have, if it rains, I'll take my umbrella. It is raining. And then, so since it's raining, I'll take my umbrella. The first two are premises, because they're just in support of whether or not I'm going to do this final action, which is to take my umbrella, which is the conclusion. So we have two premises. If it rains, I'll take my umbrella. And then also, it is raining. That's another statement offered in support of this conclusion, which is to say, I'll take my umbrella. So those are just the basic components of an argument. You'll see premises, and you'll see usually at least one conclusion. Sometimes arguments can get a little bit more detailed or more elaborate, and then you can have sub-conclusions, but for the purposes of this class, it's just important to understand what premises are and what conclusions are. They're just two different ways. Well, premises are in support of some claim that somebody's trying to make, and then the conclusion is the claim itself that that a person is trying to argue for. So, I erase some of this. Next, we have validity and soundness. So validity and soundness are ways that we sort of evaluate an argument. So validity is an argument that has a certain structure, or what we call a syntax, that such that the logical rules that we have at our disposal, the argument itself follows all of those logical rules. So if we said that, one of the most basic examples that we'll see in this course is say that, if something happens, then another thing happens. The first thing happened, so this other thing that says it follows from it must also happen. So I used R and U here to sort of reflect the previous structure or example that I gave you. So say the first one here is a premise that says, if it rains, I'll take my umbrella. Second statement is, it's raining. And then your conclusion is, I'll take my umbrella. So this is a structure. We're only interested in the structure here. We could get rid of that whole example and just treat this as R arrow U, R, therefore U. And validity is going to say that this is a good structure, such that when you have a statement like this, followed by a statement like this, then this statement necessarily follows. And that's built into our logical rules. The structure itself is going to work no matter what. R can represent anything in this case. So let's say that if the Martians, something that begins with an R, let's just say if the Martians raid, then they will uncover Earth. And so then R is if the Martians raid, then U is they'll uncover Earth. We'll say the Martians raid, the Martians uncover Earth. None of that makes any sense whatsoever, but it is a valid argument because it has this shape to it. Shape, syntax, form, they're all indicative of the structure of an argument, and the structure is what we consider either valid or invalid. So the next term is soundness, and this is also reflected, or it builds on top of this notion of validity. So a argument or an argument is sound if it's both valid and all of its premises are true. So thinking back to the first example I gave you, if it's raining, I'll take my umbrella. It's raining, I'll take my umbrella. Well, not only does it have a valid structure, but it also has true premises, and also a true conclusion that follows from it. But that is a sound argument. If it's raining, I'll take my umbrella. It's raining, I'll take my umbrella. That's a sound argument. Thinking back of the other Martian example I gave you, if the Martians raid, then they'll find or they'll uncover Earth. The Martians raid, therefore the Martians uncover Earth. Well, that's not really a sound argument because the premises aren't really true. They're just sort of, fictitious things that I just made up there. So the first argument would be sound. The second one would not be sound because the premises are not true. So you can have an argument that is valid but not sound, but you can't have an argument that's sound but not valid. Finally, there is a distinction that I want to make between two different types of arguments. The first type of argument is a deductive argument, such that the conclusion necessarily follows from the premises. This is the same type of argument that I was just giving you. So, say, if it rains, I'll take my umbrella. It's raining, I'll take my umbrella. That's a deductive argument. Everything follows from the premises. So typically we call a deductive argument a top-down argument because everything follows from the premises. There's nothing that I have to guess about. Everything is contained within those statements such that, if it's raining, I'll take my umbrella. It is raining, I'll take my umbrella. And so it's considered a top-down argument because there's nothing that we have to import into the argument to make it make sense, or such that there's nothing that, if these premises are true, stops the conclusion from being true. In this course, we're going to focus on deductive arguments in particular, but there are also things called inductive arguments, and inductive arguments are going to be somewhat similar, but the conclusion doesn't necessarily follow from the premises. Instead, the conclusion is highly likely to follow from the premises. So, say we do a similar argument. If it rains, I'll take my umbrella. There is an 80% chance it's going to rain, so I'll take my umbrella. So that's not saying it is going to rain, but there's a very high likelihood it's going to rain. And so the first premise isn't doesn't have a probability to it, so that could be part of a deductive argument. If it rains, I'll take my umbrella. But the second premise makes this an inductive argument because there's a probability to it. There's a chance. It's a 80% chance it's going to rain. It's not saying it is raining. It's not saying it's definitely going to rain. It's just saying there's a chance for it to happen. And so based on that chance, you can make the argument that I should take my umbrella. So inductive arguments don't have the same type of strength that deductive arguments have. Typically, they are called bottom-up arguments because you take a bunch of facts that you have and you try to build a conclusion from them. So you take a bunch of facts and you try to build towards some conclusion. Typically, the person making the argument has to supply something to an inductive argument to make it follow. And so inductive arguments are a little bit weaker. However, inductive arguments are the ones that we pretty much make in our day-to-day lives. For the most part, we say, should we do this? Well, we have this fact, we have this fact, we have this fact, and taking all those facts into consideration, it seems like we should do X rather than Y. That's usually an inductive argument. However, as I mentioned before, what we're going to focus on in this class are deductive arguments. Because deductive arguments follow necessarily, so we can apply these rules and we can say whether or not an argument necessarily follows from the premises that we start with. Also, we are going to focus on validity in particular. So this class is pretty much completely about these two concepts, validity and deductive arguments. We're going to check to see whether or not the arguments that we construct are valid given the logical rules that we have set forth. And so we'll add the rules as we go from week to week. But this is the basic outline for what the course is going to be based on these two terms. We're going to look at deductive arguments and we're going to determine whether or not they're valid or invalid. In order to construct our arguments, we want to be able to simplify sentences down into just basic letters and propositions and operators. So before we get to that and understanding how we can translate sentences into basic logical statements, I want to just go over what is part of a well-formed formula, because it's important how we write these things out. Because you have to be able to write it in a language that is understandable and that follows some basic rules. So writing statements in logic have three different types of components to them. So the first ones are propositions. These are any uppercase letters, so A through Z can represent any sort of statements. And then second, we have brackets. We have three different types of brackets. Typically, you'll just see me using parentheses. I might use the square brackets from time to time, but you can survive by just using regular parentheses. And then the third are our operators. And so our operators include our five, or at least there are 5 different operators. There's the ampersand, which represents and. There is the wedge, which represents or. There is the arrow, which represents if, then. Then there is the tilde, which represents not or no. And then finally there is the double arrow, which represents if and only if. So when we go to write statements, we want to make sure that we write them in such a way that adheres to these rules. So the first notion is that, say we have some statement P, and we want to include an operator. Let's just go with the wedge. And then we would need to attach another proposition to this operator. So every operator, with the exception of the tilde, has to have propositions on each side of them. So you can't write something like this. This P ampersand is not a well-formed formula because there's something missing. The same thing applies to any of the other ones except for, again, the tilde. So you couldn't write P wedge or wedge P or double arrow R or let's see, arrow Q or Q arrow or Q and or Q and or and L. So all of these are not well-formed formulas because you have to have some other letter attached to these operators. You're missing something in each of these spots. So that's the first basic rule, is that every operator, with the exception of the tilde, has to have two different letters, one on each side of it. So I'm going to erase that. So, not all right, all right. Now, the tilde will always go on the left side of something, so you'll never see this or anything else associated with it. Tilde is always on the left. But remember that the tilde can be attached to a single letter, but none of the other operators can be attached to single letters. So we can do statements that are beyond just, something simple. So say I wanted to say I have pennies and quarters. We could represent it writing it in that way. But say I want to say I have pennies and quarters, but I don't have dimes. I could put parentheses, another ampersand, and write that. So what this says is I have pennies and quarters, but I don't have dimes. And how we're symbolizing this here and why each thing plays its role. So let's just diagnose this sentence. First, we have pennies and quarters, which are represented here. We have to have parentheses around them because that is a single statement. And it's attached to this other, much larger statement, which is to say, I have pennies and quarters, but I don't have dimes. And so, again, we see that we have this operator, and on both sides, we have propositions. So this whole thing is considered a single proposition. This whole thing is considered a single proposition. But you see how there's a left side and a right side to the ampersand here, to this operator. So this becomes one type of well-formed formula in which we'd say, I have pennies and quarters, but I don't have dimes. The ampersand can mean both and but. as we go through translations, you'll pick up on sort of the keywords, and I'll flag them to give you an idea of how to translate sentences using some of those keywords to determine how to write them out or which operators you should expect. Just for right now, I want you to recognize that what makes a well-formed formula is that we follow the rules such that every operator, with the exception of the ampersand, must have propositions on both sides. The tilde here has to be on the left side of a proposition or a much larger statement, which you'll see, but it's always on the left side of whatever it is negating. And then also we have parentheses that show where the statement is being divided up. So you couldn't write this statement like this. The reason why is that you have to make clear which operator is going with which letters. So this right here, you have two competing operators, both of them ampersands. And it's not clear whether or not this Q goes with this not D or if it goes with the P. So you have to have parentheses or brackets over these different propositions to be able to distinguish where this letter goes. So in our instance, we made brackets here, or we put parentheses here, but we could have also, let's see if I can get that, we could also have put parentheses here, and that completely changes how the sentence gets read. So instead of saying like up here, we said I have pennies and quarters, but I don't have dimes. This says I have pennies, but I also have quarters and I don't have dimes, which logically makes about the same amount of sense, but semantically there's a difference there. Imagine if I said, let's see, this ampersand, if we change this ampersand into, say, an or. Now this statement here says I have pennies and either I have quarters or I don't have dimes. But if we erase this, erase these parentheses, this could say I have pennies and quarters or I don't have dimes. So again, the content is changed by how we place these brackets or these parentheses, and so it's important to recognize that these parentheses play an important role by distinguishing how these operators are being divided up. A good rule of thumb too for the future is that every operator will only have two letters, and if there are more than two letters, there's more than one operator. So let's just do T. And so when you put parentheses around something, the parentheses have to go around two terms. And this will get a little bit more elaborate, but this is now considered a single term because we grouped them up, and this is a single term because it's by itself. As we go through these translations, this will make a little bit more sense, but I just wanted to give you the idea of what's part of a well-formed formula. So just to recap, we have letters, capital letters specifically, then we have brackets, and then we have our different operators. So those are the three different things that will make up a well-formed formula. Let's do a couple translations. I'm just going to go through these and show you how they're done. And then in the next presentation, I'm going, or at least the next following presentations, are just pretty much going to be practice problems because translations will be part of the first exam, and I just want you to be able to have some comfortability with doing that. We won't spend more than this week and maybe a little bit next week on just doing some practice problems of translations. But again, this will be part of the exam, so I want you to at least feel pretty comfortable with translating some of these sentences. So the first sentence that I have is Nathan goes to the park and to the restaurant. I put in parentheses the different letters we'll use to symbolize each of the statements here. So when I go to write them, I'll just use the letters there in the parentheses to represent them. So first, we see we've got two different propositions. We've got a P and an R. So when we go to translate these, we can go ahead and pick out where our letters are. We have a P and an R. We're going to have something that joins them up, but right now we're not sure. But we have a P and an R in the statement. So we'll go back through and we'll look at the sentence. Nathan goes to the park and to the restaurant. And is a signifier that our operator that we're going to need is an ampersand. So an ampersand again just means and or but. And so when we go to translate, that's all we're doing. We're looking for what our propositions are, which our propositions are going to be flagged, particularly in these cases, just by the parentheses. When we move on to translations, what I'm going to do is I'm going to give you a dictionary that you can just use to translate from, but on these first translations, I just want to just make it basic and go through sentences. So ampersand signifies and or but, and we do that there with this statement. So that's all we write for number one, P and R, or P ampersand R. And that's a well-formed formula. You can put parentheses around it if you want, but they're not needed. They're just implied that they're there. So either representation is perfectly fine. So with this second statement, let's look at what letters we have. We have either Will walks to the store or he runs to the store. So we have W and R. Let's see if we can figure out what our operator is. So we'll go back through the sentence. Either Will walks to the store or he runs to the store. So or is going to be represented by our wedge. So we have W or R, and that's all that we have there too. So whenever you see or, either or, that's always going to be the wedge. And just to rewrite it so it looks a little bit cleaner. So that's going to be W or R. So don't confuse this thing with a V. It's just a wedge. It's a lowercase v, but remember, you'll never see any lowercase letters in propositional logic here. So the little V-shaped thing is a wedge, and it represents or either or, whichever one you might come across, but it's always, there's or somewhere in the sentence. Let's look at the third one. Elena does not go to sleep at midnight. So here again, we have a proposition which is represented by S, which is sleep. So Elena does not go to sleep at midnight. Let's look to see if there are any operators, and we can go ahead and stop here because Elena does not go to sleep at midnight. So not is represented by the tilde. So to symbolize that sentence, we just put tilde S. Elena does not go to sleep at midnight. Looking at the fourth one, if Doris wants ice cream, then she drives to DQ. So we see there is an I for ice cream, and we see there's a D for drives to Dairy Queen. So now let's go back through and see what our operator is, and right off the bat, we can see it's an if then. If Doris wants ice cream, then she drives to Dairy Queen. So this is called a conditional statement because it's an if then, and if thens or conditional statements are represented by arrows. So if Doris wants ice cream, then she drives the DQ. And that's all we're doing for that. Finally, we have the fisherman's sail if and only if the weather is favorable. Again, we can see that we have an S, we have an F, and now we have to just determine whether or what our operator is. So this fisherman's sail if and only if the weather is favorable. So if and only if is represented by a double arrow. It's called a biconditional. And so in this sentence or in this statement, we're going to symbolize it using the biconditional. And we have our two propositions, the fisherman's sail, and then we also have the weather is favorable, represented by the F. And so that's going to be how we symbolize that fifth sentence. So these are all basic translations using just one operator and the amount of propositions that are associated with it. In the next few slides, we'll do a couple of more complicated ones just to give you an idea about how to make these more complex propositional statements in logic. On this slide, we're going to do a couple of more complicated translations. Same premise as before. The propositions are flagged by the parentheses, so whatever letters within those parentheses, that's how, or that's the letter we're going to use to symbolize it in our propositional statement. And then we're going to look to see where or what operators we have and where they need to go to be able to create a well-formed formula for each of these sentences. So let's start with the first one. If Cassie does her homework, then she can take the dog for a walk or watch some television. So we see that there are three different letters that we have. We have an H, we have a D, we have a W. I'll change that D real quick. So, and I leave space in between them because there has to be some operator that goes between them. You can't have two letters that are combined together and are butted up against each other. There has to be some operator between each proposition in propositional logic. So now let's go back through and see if we can find what our operators are. If Cassie does her homework, then, so we see an if-then statement. So what do we use to symbolize an if-then statement? We'll use an arrow. Then let's look at the rest of the sentence. Then she can take the dog for a walk or watch some television. So what does the or how does the or get represented in propositional logic? We just use a wedge. There we go. Now, are we done? No, because this violates our well-formed formula rules. We have operators that are attached to multiple letters at the same time, but there's no clear distinction between which statements the operators go with. So we need some parentheses to go in here. So let's read back through our sentence and see where our parentheses might go. If Cassie does her homework, then she can take the dog for a walk or watch some television. In this instance, it seems like the comma is telling us that the possibility is either she takes the dog for the walk or she watches some television. So the conditional statement, when we satisfy the condition, she does her homework, she'll either take the dog for a walk or watch some television. Now, if we would have written it the other way, let's say we get rid of these parentheses I just put in there and put it this way, what this sentence is saying with the parentheses there is that if Cassie does her homework, then she'll walk the dog or she watches some television. So it's going to be either the conditional statement saying she does her homework, then she walks the dog, or she just watches television and she doesn't worry about doing her homework or walking the dog. That's fundamentally different than the way we symbolized it before, putting in our parentheses here and here, because this representation of the sentence says she has to do her homework before she does one of those other things. She does her homework, then she'll either walk the dog or watch some television. But the homework has to be done first, is what this sentence is saying. And that seems to capture what we're trying to get at with this sentence. So we probably would symbolize it this way rather than this way, because it sounds like um, this sentence is trying to get at the point that she's going to do her homework and then she's going to do one of these other two things. So it wouldn't be this, but we would probably write it like that. So that's the first one. Let's look at the second sentence. Manuel both writes and reads each day, or he takes a break. So again, we can go ahead and just write out what our letters are because they're given to us. And now let's look back through to see if we can find our operators. So Manuel both writes and reads. We have an and then also we have a both, so both and. And so that signifies that we have an ampersand. And now let's look at the rest of the sentence. Manuel both writes and reads each day, or he takes a break. So or represented by the wedge. And now we have the question again as to where our parentheses go. So Manuel both writes and reads each day, or he takes a break. To me, it sounds like the options are either he does both reading and writing, or he takes a break, which we would symbolize like this. And that makes more sense than saying or writing it like this, because I'll read you back this sentence. Manuel writes and he either reads or takes a break. That doesn't seem to capture what's going on in this sentence, especially since writes and reads is followed by each day. So it sounds like each day applies to both reading and writing. And so we would probably want to group those together. And then takes a break is off by itself, so we would probably keep that outside the parentheses and then put them together. So what we have here is or not a conditional statement, but a disjunction. We call it a disjunction because it's an either or. And so you have two possibilities. Either Manuel is writing and reading, or Manuel is taking a break. And so we would probably keep it written this way and not this way, because it seems to capture the way in which we're saying that Manuel is both writing and reading each day, or he takes a break, one or the other. So that's a disjunction statement. So we want to have the wedge outside the parentheses and move that way. So let's look at the next one. Ada goes to the supermarket if and only if she does not have lettuce or she does not have frozen pizzas. So we have S, L, P. And now let's look back through what we have. We have Ada goes to the supermarket if and only if. So if and only if is going to be represented by a double arrow. I'm going to leave a little bit of room because I know what's coming. If and only if she does not have lettuce, or she does not have frozen pizzas. So now we've got quite a few operators here. We have 2 tildes and we have a double arrow. Uh, we also have a wedge. We also have we also have a wedge, but we've only got 3 different letters here. So how are we going to use the parentheses in this situation? So an if and only if statement is a biconditional, meaning that it says if one side, then the other side. And it doesn't matter which side, either happens. So how do we want to symbolize this? If we symbolize it, we can symbolize it in one of 2 ways. We can symbolize it like this, or like this. Let me read you how this comes across if we put the parentheses here. If we put the parentheses there, it's saying Ada goes to the supermarket if and only if she does not have lettuce, or Ada does not have frozen pizzas. So here, it seems like the biconditional is tied to only her not having lettuce. But is that really what that sentence is saying? That doesn't seem to be what the sentence is saying, because it seems like either, or Ada will go to the supermarket if either she doesn't have lettuce or she doesn't have frozen pizzas. So what's motivating Ada to go to the supermarket? Either not having lettuce or not having frozen pizzas. And we capture that by putting the parentheses around the tilde L and the tilde P. So this way of symbolizing the sentence is saying Ada will go to the supermarket if and only if she happens to be out of lettuce or she happens to be out of frozen pizzas. If she doesn't have one of those things, she's going to the supermarket. That's what that sentence is saying, and that seems to capture it better than the alternative version that we looked at prior, which was to just say Ada will go to the supermarket if and only if she's out of lettuce or she doesn't have frozen pizzas. Those two don't seem to be related in the same way that the sentence is trying to convey. So the way in which we represent it here seems to make the most sense. S, double arrow, and put the parentheses, and then not L or not P, not having lettuce or not having frozen pizzas. So let's do this last one. Irfan either walks or bikes to work, but he never drives. So again, let's just start with the basic letters that we've got. WBD. So Irfan either walks or bikes to work. We have an or, so we know we're going to have a wedge between those. Bikes to work, but, so that's suggesting an ampersand. And then never is also, a negation, and never or not or no. We could symbolize that as a tilde. So anything that's ever a negation or related to a negation, those are going to be tildes. So this is what we have written out as our sort of basic sentence, but now we still need the parentheses because, again, we have a single proposition. The B here is attached with both a wedge and an ampersand, so we have to be able to figure out how we're going to distinguish these two. So let's look at the sentence again. Irfan either walks or bikes to work, but he never drives. So it seems like we have the options here of walking or biking to work. So we would put the parentheses around these two. Irfan either walks or bikes, but he never drives. So the ampersand is just saying there's this other clause in this sentence, but he never drives. And we're going to attach it to the first one. And then the tilde is just negating the fact that Irfin drives, so that's just saying Irfin doesn't drive. So this seems to capture the sentence in its most fundamental sense, because it's saying Irfin will do one or the other. He'll either walk or he'll bike to work. That's He's either doing one or the other, but he can't do both. But he's gonna pick from those. But we also know that he'll never drive, so we just tack that on to the end of the sentence as well, with the ampersand and the not D. So those are just some more complicated translations. On the next slide, we'll do some more translations, and then in the following presentations, we'll just keep on practicing them. So it might seem a little bit confusing right now. What I want you to be able to recognize is that how we use parentheses, what our operators are, what the terms are that signify our operators, uh, and then also just how to sort of piece these together through time and through practices through the next however many presentations we have on translations. It should make a little bit more sense. So just bear with me and make sure you keep on practicing. But we'll do one more slide of them here, and then we'll call it a day for this presentation. From now on, I'm going to give you what's called a dictionary to do these translations. So if you look at the top of the screen here, you have these three sentences or three statements, and they're all represented by a single letter. So this is usually called a dictionary or a legend. We can call it a legend if we want. I usually just call it a dictionary. And so you'll use this dictionary to translate the sentences below. This is just a little bit more of an easier way. I wanted to show you how we can translate any sentence in the previous slides. Here, I just want us to be able to practice just making the translations themselves. So the sentences will pretty much all sound the same, but the way in which they're hung together are going to be different. The operators that we use in each sentence aren't going to be the same. So let's look at the first sentence. If the pirates raid, then they will sail away. So looking at our legend or our dictionary, we have pirates raid, and that's associated with R. So we'll symbolize that with an R. Let's look at the other thing that we've got here. A sail away. That's just an S. So that's how we use our dictionary. We see pirates raid. We look in our dictionary, the pirates raid. Then also we have they sail away. We see the pirates sail away. So that's how we use the dictionary. So R and S are our propositions in this sentence. So now let's look back through the sentence and see what our operator is. We have an if then. So if the pirates raid, then they'll sail away. And then so we represent the if then by an arrow. So if thens are arrows, and that's all that we have to do for that sentence. If the pirates raid, then they will sail away. Let's look at the next one. So we have if the pirates raid, the pirates raid and sail away, but they do not bury the treasure. So we have all three of our sentences, all three of our different types of statements. We have the pirates raid, that's an R, they'll sail away, and bury treasure, so RST. So now let's look back through to see what our operators are. We have an and, so the pirates raid and sail away. An and is an ampersand. And then we have the pirates raid and sail away, but they do not bury the treasure. We have a but, and buts are represented also by an ampersand. And then we also have a not. Remember, whenever you see a negation, a not, a no, a never, there's just going to be a tilde in front of whatever it's negating. In this sentence, it says they do not bury the treasure, so our tilde will just go in front of our T. So now we need some parentheses, because again, that S is connected to two different ampersands. It's not clear which one it goes with. So let's look back through our sentence. The pirates raid and sail away, but they do not bury the treasure. In this instance, what tells us how to do our parentheses is going to be the comma. So a good rule of thumb is whenever you see a comma, it's telling you which part of the sentence goes with which, or which clause is separated by which clause. So since we have this comma here between sail away and not burying the treasure, or this but they do not bury the treasure, it tells us that the parentheses will likely go around the first two letters, which is R and S, and then the other part of the clause is going to be an addition to it. So we'll just keep this separated like this. So in this instance, comma will help you out in telling you how to do the parentheses. So the pirates raid and sail away, but they do not bury the treasure. So that would be how we formalize that sentence. So let's do the third one here. Let's see. Pirates sail away if and only if the pirates both bury the treasure and raid. Let's use yellow. So again, we have all three letters. This is usually a step-by-step process. If you haven't recognized, this is how I typically do it. I find what my letters are. I have my S, I have my T, I have my R. However they appear in the sentence is how they'll always get marked down when we go to symbolize it. They're always in the same order. I'll never try to be sneaky and put one part of the sentence somewhere else and expect you to put it elsewhere in the sentence. Sometimes that happens, but I'm not going to do that to you. Again, this is an introductory level course, so just keep it basic for right now. So we've got our sentences S, T, and R, or we've got our statements. So now let's go back through and find our operators. Well, we have an if and only if. So an if and only if, represented by a double arrow. The pirates both bury the treasure and raid. So we know we've got that. So now we have to figure out where our parentheses are, because our T both has a double arrow attached to it and an ampersand attached to it, and it can only have one at a time. So let's look back at the sentence. The pirates sail if and only if the pirates both bury the treasure and raid. Here, both is going to tell us how we're going to use our parentheses. Because what's it say? It's saying that both of these things have to happen if the pirates are going to sail away. So when we go to symbolize it, we're going to put our parentheses here because it's saying both of these things go together. They both bury the treasure and raid. So when we go to write the sentence, the pirates sail if and only if pirates both bury treasure and raid. So those are just some examples. The next presentations will be nothing but translations, so you'll have a lot of practice moving forward with how to translate sentences. In the next presentation, I'll go back over what the keywords are for each of the different operators. But this course in general, not just translations, but once we get to truth trees and natural deduction, is mainly about doing a lot of practice problems. So we're going to keep doing a bunch of practice problems, and that's how it's going to sort of get into your brain about how to do this. The nice thing about this course is we don't do that much content. Instead, we spend a lot of time on trying to do three things: translations, truth trees, and natural deduction. And so once you get one of them down, then it becomes pretty much like second nature, but it just takes a lot of practice to be able to understand how this gets done. So I'll conclude this presentation, and then the next presentations we'll just sort of do a bunch of practice problems.